Here we're briefly going to go over the derivatives of inverse trig functions. So I'm going to show you the proof for the arcsine derivative, which I think is pretty cool, and then I'll just tell you the rest. Here we have y equals the arcsine of x. Now what I'm going to do here is I'm going to take the sine of both sides. This cancels the arcsine on the right. From here, I'm going to differentiate the equation with respect to x, like so. In the power rule, we know this is 1, and here we're going to have to implicitly differentiate sine of y. So remember, an implicit derivative is df dy times dy dx. df dy in this case is just cosine of y, and then we have to multiply by dy dx. Now I'm going to divide both sides by cosine of y to solve for dy dx, like so. I want cosine of y in terms of x, and I already have sine of y in terms of x. I'm going to use the trigonometric identity that relates them to make a substitution. We know that sine squared y plus cosine squared y equals 1. And solving for cosine of y, we get that this is equal to the square root of 1 minus sine squared y. So I'm going to plug this in up here, like so. And up here, we said that sine of y is equal to x, so I'm going to replace sine of y here with x. Now we have that the derivative of the arcsine of x is equal to 1 over the square root of 1 minus x squared, and that is our answer. So we show that the derivative of arcsine of x is 1 over square root of 1 minus x squared. And here are the rest. They're all in their general form for anything you put inside the function. And notice that the derivative of arc cosine is just the negative derivative of arc sine. The derivative of arc cotangent is just the negative derivative of arc tan. The derivative of arc cosecant is the same as negative derivative of arc secant. So in reality, all you have to memorize are these three starred ones, and just remember that their co-counterpart is negative. For our first example, we're going to find the derivative of arcsine of x squared. Remember that the derivative of arcsine is 1 over root 1 minus u squared times du dx. And our u here is x squared. So all we have to do is just plug in. If u is x squared, then u squared is x to the 4th. And our du dx is, by the power rule, 2x. So our derivative is 2x over the square root of 1 minus x to the 4th. For our second example, we're going to find the derivative of arctangent of e to the x. Remember that this derivative is 1 over 1 plus u squared times du dx. And like before, all we have to do is just substitute. So we have u equal to e to the x. So u squared is e to the x squared, or e to the 2x. And our du dx is e to the x because the derivative of e to the x is itself. Our final answer is e to the x over 1 plus e to the 2x. And that's it for derivatives of inverse trig. It's not really that much here, it's just memorizing 3 derivative rules. And as a whole, derivatives of inverse trig aren't that common. The most popular one I see people tested on is the derivative of arctangent. If you're going to memorize any of them, I'll memorize this one. And those were the derivatives of the inverse trig functions.